Okay, here we go on the third podcast of Chapter 16, which is on 16.2, Concentrations of Solutions. So, concentration is a measure of the amount of solute that is dissolved in a given quantity of solvent. There are several different units of concentration that we're going to talk about. The first one, though, we've talked about many times before, and that is molarity. Molarity is represented by a capital M, and it is the moles of the solute divided by the liters of solution. So let's try an example. We have a salt solution that has a volume of 250 milliliters and contains 0.70 moles of NaCl, and the question is, what is the molarity of the solution? So because molarity is moles per liter, we're going to take this volume and we're going to convert it into liters to start with. So we have 250 milliliters. I hope you like how I figured out how to make my pen purple now. Very exciting. And we're dividing by 1,000. Hopefully you remember how to do that. And we get a volume of 0.250, if I can get the point to show up, liters. So now we can calculate the molarity by putting the moles on top and the liters on the bottom. Okay, in this section there are lots of calculations. If we were doing this in class right now, I would pause and ask everyone to take out their calculators and to get the answer, and then we would see how we did. So what I would suggest at each of these sample calculations is that you pause the podcast, you try the calculation, and then you start the podcast again and see if you got the correct answer. Because just watching me do it isn't the same as trying it yourself. So that's my suggestion. So you should pause right now and try the problem. And now start up the podcast again, and hopefully you got the answer, 2.8 molar to two significant figures. Bad box, but you get the idea. Okay. Here's another example of a molarity calculation. We have an aqueous solution that has a volume of 2 liters and contains 36 grams of glucose. What is the molarity of the solution? So we have a volume, see now I have orange, of 2 liters, and we have a mass of 36 grams. Hopefully you remember that glucose is C6H12O6. And the question is, what is the molarity? So remember that molarity is moles divided by liters. So we're going to have to take this 36 grams and put it into moles before we can go on. So right now I would like you to pause the podcast, and I'd like you to find the molar mass of glucose, convert the 36 grams into moles, and then plug in the moles and the liters and solve for the molarity. So pause now and do that work, and then you can restart the podcast and see how you did. Okay, so hopefully for the molar mass you got 180.18 grams for glucose, giving us 0.1998 moles. Remember, you don't want to round too much in the middle of the problem, so even though we don't really need 4 sig figs, I'm leaving that many sig figs so that I'm not rounding in the middle of the problem too much. 1998 moles. I mean, best to just use the unrounded number still on your screen, divided by 2.0 liters, and that gives me, to 2 sig figs, 0.10 molar solution. Good? Let's try one more. Okay. What mass of solid calcium chloride is required to make 175 milliliters of 0.85 molar calcium chloride, and how would you make the solution? Okay, so to do a problem like this where they want to know what mass you need, you always want to start with the volume. So here's our volume, 175 milliliters. I see that whatever color this pen is supposed to be doesn't look so good on my light purple background, but oh well. I'm converting it into liters. And now I'm going to multiply by molarity to get to moles. So remember that that capital M for molar represents the moles of the solute, calcium chloride, over the liters of solution. So I took this and I split it up like that. And it's like a conversion factor between moles and liters. Now the question wants to know the mass of solid calcium chloride. So here's what I want you to do. I want you to find the molar mass of calcium chloride, fill it in up here, and then go ahead and finish the problem. So stop the podcast now and try that. Okay, if you're watching again, hopefully you tried the calculation already. The molar mass is 110.98 grams, and if you do the math, you get 17 grams of calcium chloride. Now the question says, how would you make the solution? So this is a review. We've made these solutions many times, but just to remind you, I'll just jot down a few notes here. You're going to obtain 17 grams of calcium chloride on a piece of weighing paper. You're going to add it to 175 milliliter. Remember the name of the piece of equipment? Volumetric flask. I actually think I have a picture down here. Let's see. Oh yeah, there we go. Okay, so here's adding it to the volumetric flask. Now we're going to add a little water. And we're going to swirl till the solid dissolves. That's this. And then we're going to fill to the line with water. And that's that. Okay, so this is a volumetric flask, and that's how you make a solution from the solid. You've done it before, and you have to do it again in the third lab in this chapter. Moving on. Making dilutions. Okay, so sometimes you're going to be given a concentrated solution and asked to make a dilute solution from it instead of starting with a solid. So the example that we looked at, you were starting with a solid and making the solution from there. Now we're going to look at a scenario where you're given the substance already as a solution, it's just more concentrated than you want it to be. So what you can do is use this equation, M1V1 equals M2V2. The M1 and the V1 represent the original solution, and the M2V2 represents the new dilute solution that you are making. Molarity times volume gives you moles. Since the only thing you're doing is adding water to your solution to make it more dilute, you're not changing the moles of solute. So the original moles of solute and the new moles of solute are going to be the same as each other. Okay, so let's try an example. How do you prepare 250 milliliters of 0.50 molar HCl from 12 molar HCl? So we have to identify each of these numbers as one of the variables in the equation. How do you prepare 250 milliliters? Well, that doesn't sound like what you're starting with. That sounds like what you're trying to get, the new solution. So that would be volume 2, and this would be molarity 2. That's what you're trying to make. And you're preparing it from 12 molar HCl, so that would be M1. So the question is, what's V1? How much of that concentrated solution do we need? Okay, so we're using the equation M1V1 equals M2V2, and we're just plugging in the numbers. So right now, you're going to try and plug in all the numbers that I gave you and solve for V1. So stop the podcast and do it, and then start it up again to check your work. Okay, hopefully you've already tried it. We have 12 molar for M1. V1 we're solving for. M2 is 0.50 molar, and V2 is 250 milliliters. You can go ahead and leave the volume in milliliters as long as it's in milliliters on both sides. Okay. So if you do the math and you solve for V1, you get 10 milliliters. That number represents how much of the concentrated acid you need. But the question is, how do you prepare the solution? Well, if you want to make 250 milliliters of solution, and 10 milliliters of it is the concentrated acid, what's the rest of those 250 milliliters? Water. So you're going to add 10 milliliters of 12 molar HCl, that's the concentrated acid, to 240 milliliters of H2O. You always add the acid to the water. Not that you're really going to do this because it's dangerous to work with 12 molar HCl, but that's how you would do it. So that's another way to make a solution. Alright, so all of these examples were about molarity, which was our first unit of concentration. Let's look at another unit of concentration, which is percent by mass. Percent by mass represents the mass of the solute over the mass of the whole solution and multiplied by 100. We saw something very similar when we found the percent of water in a hydrate. You take the mass of the hydrate, the mass of the water divided by the mass of the hydrate, times it by 100, same idea. Here come some examples. A solution of potassium nitrate dissolved in water is 15% KNO3 by mass, and they want to know how many grams of KNO3 would be in 275 grams of this solution. So you take your 15%, and what that represents is 15 grams of the solute, which is the actual KNO3, in 100 grams of the solution. And now you can set up a proportion. If 15 grams of KNO3 are in 100 grams of solution, how many grams of KNO3 are in 275 grams of solution? And now you just solve. So turn off the podcast and solve for x, and then turn it back on again. If you did this problem correctly, you'll be getting 41 grams. Here comes our second example. A 12% hydrochloric acid solution contains 14.9 grams of solute. What is the mass of the solution? 12% equals 12 grams of the solute, which is the HCl molecules, in 100 grams of the solution, which is the water and the HCl. So we're going to set up a proportion again. 12 grams of HCl for 100 grams of solution equals, now this one says it contains 14.9 grams of solute. So that's going to go on top where the solute is, the HCl. Trying to make bigger dots here so they're easier to show up. And then the thing that's unknown is the mass of the solution. So that's where we put our x, under the mass of the solution. Pause and solve for x, and then turn the podcast on again. So for x, I'm getting 124.2 grams, but that's too many sig figs. We only need 2 because 12% only has 2, so we round it down to 120. And that's how you do percent by mass. Okay, the last unit of concentration we're looking at in this podcast is called mole fraction. Mole fraction is represented by an X. And the reason for that is that there's so many things that M stands for, mass and mole and molarity, etc., that they just picked a totally different letter, and it's a capital X, and it is the moles of the solute over the total moles of the solution. So it's similar to percent by mass, which would have mass of solute over mass of solution. It's just in moles instead, and there's no multiplying by 100. So it has no unit, and not multiplied by 100, not made into a percent. Here's an example of a calculation involving mole fraction. You're asked what is the mole fraction of each component in a solution made by mixing 300 grams of ethanol, and there's the formula for ethanol, and 500 grams of water. So because all of this is supposed to be in moles, we're going to convert to moles here. So I want you to convert 300 grams of ethanol into moles and 500 grams of water into moles. And then you can see if you can figure out how to plug it in there. If not, turn back the podcast back on again and I'll show you how to plug it in. Okay, so pause the podcast and try converting to moles. All right, you've turned it on again, so 300.0 grams of C2H5OH. I think I lost a 0 in there. Okay, molar mass of ethanol, I have 46.08 grams. And that gives me 6.51 moles of ethanol. Now I have my 500 grams of water. And I'll go ahead and convert that. And I get 27.7 moles of water. Now, I need the total moles because that's what goes in the bottom. When it says total moles of solution, that means the solute and the solvent together. Here's my solute, here's my solvent. I'm going to put them together, which gives me 34.21 moles. Okay, so the mole fraction of ethanol will be the moles of just ethanol over the total. And hopefully you got 0.1900. I need 4 sig figs there. Now, to get the mole fraction of the water, we could set it up 27.7 over 34.21, or we can just say 1 minus 0.1900, because together they make 100%, and 100% in decimal form is 1. And so you get 0.8100 for the mole fraction of the water. And that's mole fraction. And that is the end of section 16.2.